Hi guys, in this video we're creating Cinderella versus Pumpkin endless render game using basic HTML, CSS, and JavaScript. And it's inspired by this classic Chrome Dino game but with Cinderella as the main character. It's fun and easy, so without further ado, let's get coding and have some fun! Let's first look at what we're building. So we want the character to be able to jump using space or arrow keys, and we also want a running timer of the score as well as the high score, and when the user fails they should be able to restart the game. In this video I'll be using Visual Studio Code, and make sure to import the folder, an empty folder. Mine is called Cinderella Run. Then we just need 3 images. I drew the Cinderella, but I downloaded the pumpkin and the background from Pinterest. Then I used this app to make some animating frames. This is like a sample one that I had for you guys. You can draw pixels or you can use an eraser to erase, move things around. And you can see the animation on the right, a little short animation. And you can save using GIF or PNG sequence to the resolution that you like. Once we have the images, we just need 3 more files: JavaScript, HTML, and CSS. This is where you can create a new file. I'm not going to type anything because I already have everything I need. So let's look into our HTML. It's just our basic backbone, HTML tag, title, and linking to our CSS file, which is right there. And I imported these from Google Fonts. And this one is our body, and we want game, and inside the game we want player, ground, and game over overlay screen, and we also want our scoreboards. This is just our backbone, and make sure to also link your JavaScript right here. Let's look at our styling for our game. Let's go to Style CSS, and we see the width and height of the game is specified right here, and the position is relative because everything else, like the ground, is going to be absolute, and the ground is 40 pixels up the bottom frame of the game. This is how we're going to set up our player logic. We're going to have an inner div called player sprite, and this is where we will be adding our character. So if we go back to CSS, then we'll see that the position is absolute because we're going to move the obstacles, but the character is just standing in place and it's just a GIF sprite as a background. This is how our jumping logic works, but first we need to import all of our element IDs from the HTML into our JavaScript. And then we'll have our constant ground 40, which is like 40 pixels above the border of the game, and we'll have our y, which is the location of our character, then our character's velocity, and gravity will be 0.8, and jump power is how high the character can jump. And of course we'll have our constant jumping, and game over is both false when the game first starts. And we need just like a simple function for this. So if the character is not jumping and if it's not game over, then we want the character to jump, and the height of the character will be the jump power, which is -20. And for it to jump, we need a key that needs to be pressed. It's either space or arrow up, and we call the jump function right here, and this is how the character jumps. So games need a loop that keeps updating the screen. So in our game we're going to use update, and this request animation frame, it updates the screen like 60 times per second. So let's look at how the player physics works. So this part of the code is just making sure that the player gets pulled back down, and this part is making sure that the player doesn't fall deeper than the ground. And Yeah, that's what we did here. Let's create some obstacles. So if it's game over, then we don't want to do anything. We don't want any obstacles. If not, then we want to create a div and we want to add the obstacle inside it. And we want to randomize the pumpkin size using our JavaScript. And only after that, then we will append our obstacle child into our div. Okay, and every 2 milliseconds we want to keep checking if it's game over. If it's game over, then we want to clear the timer. Otherwise, we're going to move the obstacle to the left a little bit, and we want to check collision. And if the obstacle is no longer in our view, then we want to clear the interval and remove the obstacle. Now that we have our create obstacle, we can create lots of obstacles using our spawn obstacle function. We're going to determine the minimum gap that the obstacle should be in between, and also randomize the delay at how fast the obstacle is created. How to check if there's been a collision? We just looked at our player's rectangle, the bounding area, and the obstacle's bounding area. We get the information from the browser, then we just check if they touched. If they do, then we end the game. Our scoring system is pretty simple. We just have a constant for the score, and we will track the start time, and the score speed is 10 for every second lapsed. And we calculate the score here using the timer, subtract the start time, divided by 1000 into 10. Then we will store our high score in our local storage. We're not going to complicate with any database or anything. And that's basically it. If the score is higher than a high score, then we're going to create a new high score. Like anything, ending is just as important as starting. So we want to make sure that when the game ends, the player is on the ground. And our section where we save the high score that we have already talked about in our previous section, then we want to remove all our obstacles. That's it. That's short and sweet. How do we reset the game? All we have to do is clear all the timeouts that we have for our obstacles. Then we want to reset everything related to our player. Then we also want to make sure that we want to respawn the obstacle because the game has restarted, and also add an event listener to reset the game. Hi, for seeing this, you made it till the very end. Make sure to like and subscribe, and I hope to see you in the next one. Bye for now.